afternoon, everyone. I am Emily, and welcome to my presentation of my final year project. I study in double degree in computing and management. So, here I would like to express my special thanks to the School of Optometry and to Mr. Peter Pang, the Associate Consultant Optometrist, who provide the needed information throughout my project. And here is the agenda of today. And here is the introduction. The background of the simulation is based on the optometry clinic at PolyU, as it is looking for improvement in service. An issue identified by the clinic is that there are late dismissal of eye examination conducted by student optometrists, and it is observed that one of the factors of this delay is based on the waiting time, which is quite long for the teacher optometrist to perform the examination. So therefore, to improve their service, the optometry clinic at PolyU could be minimizing the late dismissal of optometry service with the changing number of teacher optometrists. However, when we are changing the resources, the result may not be expected, which may pose costs in the implementation. Therefore, to avoid high costs and the undetermined consequences, 3D simulation could be adopted as it can visualize the changes. Then we can make decisions with the consideration of various factors. The aims of this project is to simulate the operation in the optometry clinic at PolyU. It is to look for the optimal ratio of student to teacher ratio, which can achieve the acceptable percentage of prolonged eye examination. The objective is to simulate the optometry service, test the model, identify the optimal ratio, and to demonstrate the use of simulation tools in decision making. So the scope of my project is simulating the 90-minute section of the optometry service, which has 24 appointments a day. And the optometry service includes the registration, the eye examination performed by the student optometrist. After that, they will have the dispensing, where the patient will be purchasing their spectacles, and afterwards it will be the payment. And data from real life will be collected and inputted into the simulation model. After that, the experiment will be carried out and conclusion will be drawn on the optimal ratio of student to teacher. There are 3 problem statements. First, how to determine the optimal case without trying them one by one physically. Second, what is the optimal student to teacher ratio in the optometry clinic at PolyU? And lastly, can Flexim Healthcare assist in decision making in the optometry clinic at PolyU? And here are some literature review. The topic reviewed include discrete event simulation, Flexim Healthcare, healthcare operations management, and simulation optimization, which is used for during the conclusion. And there are also some prior researchers which applied Flexim Healthcare in their researches, and also researchers with the use of simulation of optometry clinic. And here is the project methodology. The adopted framework has 4 stages: planning, modeling, verification, and application. And the implementation approach includes the use of Flexim Healthcare, which is the 3D simulation tool. And Flexim itself is a high commercial value software. And also, SketchUp is used for building the 3D objects, which is used in the simulation model. And here is the project schedule. I started doing this project since the first meeting with Mr. Peter Pang in last July. And here comes the design. In order to reduce the variation in the simulation model, several assumptions are taken place. For example, in the model, patient will come individually without any companion. Also, patient will finish the whole process before they leave the clinic. And to reduce the complexity of the simulation model, simplification also takes place. For example, the patient are taking the primary eye care consultation in the simulation model. And apart from visiting the clinic to learn about the process and the flow of the clinic, I also interviewed Mr. Peter Pang and his colleagues to collect some data. The data includes the process time of each activities and the patient arrival and variation. The design of models include the arrival of patient, which is the data collected through interview. And here is the patient flow. First, the patient will be arriving in the clinic, and then they will perform registration. Afterwards, they will be waiting for the pretext, and from waiting for pretext until the teacher examination, this process is the eye examination. And afterwards, it will be dispensing, payment, and departure. And here comes the project demonstration. So on this side, you can see that this is the flowchart function, which is built in the Flexim Healthcare. With this function, it can define clearly the relationship between different functional areas. And on here, you can see that it is the patient track, which is also function of Flexim Healthcare. It defines the activities of the patient which they will experience in the clinic. And here is the simulation model. So currently you are looking at the reception area. Sorry for the speed. Okay, so let me run again. So you can see patient arrive, and then they will take the registration. Afterwards, they will be waiting in the waiting room area, and the student optometrist will be coming to the waiting room area to pick up the patient, and they will go into these devices to take the pre-tests. There will be at most 3 tests that they would take before the optometry examination. So you can see there will be more patient incoming as there are variation in their arrival. So after they perform the pre-test, they will be going into the optometry room and perform the eye examination by the student optometrist. And in this scenario, there would be 1 teacher, which is simulating the scenario with just 1 teacher. And after the examination, the patient will undergo post-test after the dilation. So they will be taking some tests in these 2 machines. And afterwards, they will also go back to the optometry room to undergo the post-examination, and the teacher will be would perform the examination on the patient afterwards. As you can see, the orange trousers represent the teacher, and the black trousers represent the student. So this is the flow of 1 appointment. And so from the dashboard, we observe the waiting time and also the milestone time, which is the process time of the eye examination at the optometry service. So we can see that the data in the dashboard updated instantly. And so we can speed up the process and observe the results. So we can observe that there are really a long time waiting for the teacher over here. And with this information, it is verified with the optometry clinic, and then we conduct the experiment. The experiment includes 6 scenarios where the teachers ranking from number 1 to 6, and the replication is 150 minutes, 150 replication. And we can explore any scenario you want. For example, scenario 2 with 20th replication. Therefore, with the experiment, we can also identify that there are changes in the waiting time. Although in scenario 2, which there is 2 teachers, the waiting time for teacher dominates. And so we are not going to demonstrate running for the 6 scenarios, and it would take much time. So the result will be in the PowerPoint. So here comes the implementation of the model. It includes the layout design where most of the objects are available in Flexim Healthcare. However, some of them are not available, so I need to create them through SketchUp. And here is the flows chart. As mentioned in the demonstration, it is a key function which can identify and define the relationship between different functional areas in the healthcare organization. And this is the patient track, which also defines the activities and the flow of patient. And here is the design of experiment. As mentioned, there will be 6 scenarios with different number of teachers from 1 to 6. And there will be 150 replications per scenario. To define for the optimization analysis, the performance measure will be the acceptable prolonged eye examination, and the input variable is the number of teachers. So this is the result after running for the 6 scenarios. So from the data collected, we can observe that the waiting time for a teacher optometrist decreased to 0 when we increase the number of teachers. However, it remains steady from scenario 4 to 6. We can observe that the reason behind could be because the patient are waiting for the payment area. And for the process time of the eye examination and the optometry service, we observe that both of them has a decrease from scenario 1 to 3 and has a steady state for scenario 4 to 6. And from this table showing the percentage of prolonged eye examination, we can observe that scenario 5 and 6 has no patient experiencing delay in their service. So here comes the discussion. From the interview with the optometry clinic at PolyU, the acceptance level is defined as follows. First, the acceptance prolonged eye examination in minutes is less than 30 minutes, and in percentage is less than 20%. Therefore, from this table, we can observe that scenario 2 to 6 do not have patient experiencing more than 30 minutes delay in their service. And also, scenario 2 to 6 has less than 20% in their total percentage of prolonged eye examination. According to optimization, which is to minimize the input to obtain the objective function. Therefore, scenario 2 with the minimum number of teachers is the optimal case. As mentioned, scenario 2 is the optimal case, so the optimal ratio is 3 students to 1 teacher. And with this ratio, the average eye examination process time would be about 18 minutes, and the percentage of prolonged eye examination would be about 15.5%. This ratio is actually the current practice in the optometry clinic at PolyU. As validated through this project, it is suggested that the optometry clinic at PolyU could stay with the current practice. For the possibility of future work, the optometry clinic at PolyU could be looking into other input variables. For example, appointment scheduling, which prior researchers have been worked on to improve their service. To conclude, for the first problem statement, how to determine the optimal case without trying them one by one physically? The answer is to use some simulation tools. With the simulation model, we can define the performance measure and the input variable. Then we can observe the simulation result and apply optimization method. And then we can identify the optimal case. And for the second problem statement, what is the optimal student to teacher optometrist ratio in the optometry clinic at PolyU? Given that the performance measure is the percentage of prolonged eye examination and the input variable is the number of teachers, the optimal ratio is 3 students to 1 teacher. And lastly,